Hey gang, so we are going to do another Freyer model on inequalities. So grab your piece of white paper. You're going to draw an oval in the middle and make a plus sign. And we're going to write graphing inequalities in the middle. So if you've already got your paper, let's get going. We're going to go up here to this top right or left-hand corner. So we're going to start off, let's just review how to solve for y. Okay, we're going to say solve for y. Now this is when we have an inequality. So let me highlight this. This is our solve for y. Oh, that marker has some issues. I'm going to switch colors here in a second. All right, so let me give you this. 3x minus 5y greater than or equal to 10. Now, it's been a hot minute since we've done inequalities. And I don't know that we've ever done inequalities where we have two variables in it. But it's going to work just like any other thing when we've been solving for y. Move the x, divide the y. So here we go. If I wanted to solve this, I'm going to move the x over. So I'm going to subtract 3x. Seems like that's what we do a lot in Algebra 1. We move the x, we divide the y. Okay, so I'm left with negative 5y. I keep the inequality just the way it's written. And then we know we put the x first, so negative 3x plus 10. That's pretty straightforward. Now I need to divide by the y. So I'm going to divide by negative 5, divide by negative 5, divide by negative 5. But here's what happens. With inequalities, they get very cantankerous. And when you divide or multiply by a negative all the way across, oh, it doesn't like that. And remember, the bells and whistles go off, and we have to flip the sign. So here's what we end up with. This becomes 1, and we end up with y. This is pointing to the right. Well, I have to flip it and point it the other direction because I divided by a negative. Negative over a negative becomes a positive. 3 over 5, keep the x. 10 divided by negative 5 is negative 2. And this is my equation that I get. And so what we're going to be doing is a lot of solving for y. Lots and lots of that. Okay, so what I want you to remember. Let's put remember. This is kind of just a note for you to remember. So let's say solve for y. You move the x, and then you divide by the y. Okay, I can do that. Solve for y, you move the x, divide by y. Now, the other thing is, note, if you divide by a negative, if you divide or multiply by a negative, and we're going to put in quotation marks y, meaning if that y value that we divide by is negative, you flip, and I'm going to do flip all capital, you flip the inequality sign. Okay, I do have to remember that. Okay, you do have to remember that. Now, one other thing that we tend to always do when we are working with inequalities is we check to see if an ordered pair is in the solution. So let's write down here check, and we're going to put the ordered pair. Let's check 6, negative 3. We're going to check and see, is 6, negative 3, we'll say part of the solution. And how you check it is you simply take this and you plug it in. X goes with X and the Y goes with the Y. So here's what that's going to look like. The Y value here is negative 3. So I'm going to plug negative 3 right in here. So I'm going to say negative 3 less than or equal to 3 over 5. But instead of X, I'm going to put this 6 right here. 6. And then I'm going to say minus 2. Now all I did was take this ordered pair and I plugged it in here. That's all I did. Okay. Now I'm just going to simplify this and see what I get. So this is negative 3 less than or equal to. Okay, if I were to plug this into my calculator, so let me grab my calculator and put this in. I'm going to say alpha y equals, and I'm going to do 3 over 5. I'm going to say times 6, and then I'm going to say minus 2. Okay, it's 8 over 5. All right, I'm going to set that over there. And I'm going to say this is 8 over 5. Is negative 3 less than or equal to 8 over 5? Well, I don't really know what 8 over 5 is, but I do know it's a positive number, and this is a negative number. And so, yeah, it's going to actually be bigger than that. I believe it actually is negative 3 is less than or equal to 1.6 if you put that into a decimal. And so, yeah, that is true. And so I would come back up here and say, yes, it is. 6 negative 3, is it part of the solution? And the answer is yes, it is. Because I got a true statement. That is a true statement. This statement right here is true. So that means, oh, here comes my cat. I apologize. She's going to get in the video. No, sweetheart, you got to go away. So that means that 6 negative 3 is part of my solution. This is everything we're going to be doing. We're going to get an inequality. We're going to solve for y. Because the only way to graph this is to have it in y equals form. We're going to graph it, and then we're going to test a point, and we're going to do some things with it. Okay, I'm going to go straight across, and I'm going to be doing some new stuff over here. So, how do you graph these things? So let's do graphing basics. Now this is all about inequalities and graphing the basics of inequalities. Here's some rules we're going to have. The first is going to be what's called a dashed line. There are 4 basics that we're going to be doing here. The other one is a solid line. And then down here, we're going to say shade above. And over here, I'm going to say, you probably already guessed it, shade below. These are the 4 graphing basics. Okay, let me just remind you of something. When we were doing x is greater than 1, remember how we would put it on the number line and we would put 0, 1, and negative 1? And then I would say, okay, x is bigger than 1. So I'd go to 1 and I would circle it. And then I would say it's pointing to the right, so I would shade everything to the right because it pointed to the right. And then I would say, oh, and I don't color that in because there's no equal sign under it. But then if I changed it and I said, oh, x is greater than or equal to 1, then I would say, oh, I got to color it in because now I'm including the 1. That's the same thing about a dashed and a solid line. Dashed line means I've got a scenario where it's something like y is greater than 3x plus 1. Okay, it looks something like that. Where if I have a solid line, that would be like y is greater than or equal to 3x plus 1. Oh, there we go. Oh, there we go. You can kind of see the difference. So dashed is going to be when I don't have the equal sign. Solid is going to be when I do. All right, so let me set this to the side, and I will finish our model here. Okay, so dashed is going to be when we have greater than or less than, and it's going to look like this. An example might be y is greater than, we'll put 2x minus 3. That might be an example. That would be a dashed line. Then we would have a solid line if we had greater than or equal to and less than or equal to. And this might be y is greater than or equal to 2x minus 3. So you can kind of see the difference in those. And the big thing is that equal sign under there. Okay, shading above and below these lines. This is where it gets a little interesting, but I'm going to show you how to do it. Draw your lines again. Shading above. I just did 2 solid lines. This is what it's going to look like. You are either going to shade above the line like this. And this is really fun if you have highlighters. We tend to always kind of use the highlighters on this. or below the line like that. Now, shading above the line is going to be when we have greater than and greater than or equal to. Shading below the line is going to be less than and less than or equal to. I'm going to show you a little trick with this. And we're going to do a couple before I actually show it to you, but it's going to involve hot lava. And it does kind of make it a little easier if you struggle with which way to go. But I'm going to show you the other way first, and then I'll go into it. Okay, so these are our basics of graphing, and let me highlight this as well. All right. Sorry, we got all kinds of stuff going on. My son's playing his trombone in the background. I got another son. I don't know, he's playing some computer game, and he's yelling at everybody on the computer game because he's mad about something. Surely y'all don't do that. All right, so we're going to do two examples. We're going to do example number 1, and over here will be example number 2. I know you can't see me writing that, but I'm just writing example number 2 over here. Okay, so we're going to do x minus 4y less than 8. Okay, so here are the steps. Let me see if I can get that a little bit focused a little better. Okay, in order to work this, the first thing we have to do is like what we did up above, we have to solve for y. So I'm going to put an arrow here, and I'm going to say, first thing we're going to do is to solve for y. Now that means we have to move the x, and we have to divide by the y. That's the first thing we're going to do. So I'm going to move the x. This is like a 1 right here, so that means I'm going to subtract 1x. Okay, so negative 4y, and don't forget that is a negative right there. It has to come down with the 4. Less than, and we're going to put the x first, negative 1x plus 8. Now we need to divide by the y. So the y is a negative 4. Oh, I know what I'm thinking. I'm dividing by negative. If I divide by negative, I have to remember inequalities get super excited about that, and we have to flip the sign. So that becomes 1, and that's y. Flip the sign, and it's 1 over 4x. 8 divided by negative 4 will be negative 2. Okay, so now I've got my equation. I'm going to go ahead and draw a box around it. And I need to graph this equation. I need to graph the equation. Okay. Now, I'm going to graph it as if it were y equals 1 over 4x minus 2. And you're like, but those are the same thing. No, this one's an equal sign and this one's a greater than. I'm going to graph these points. Okay, so I'm going to come down, y'all. Let me move that up just a little bit. I'm going to draw a graph. And again, it's not going to be perfect. I'm going to start with negative 2. So negative 2 would be down here. The slope is rise up 1 and run over 4. Rise up 1 and run over 1, 2, 4. So it'd be about right here. Rise up 1, run over 1, 2, 3, 4. Okay, so I get a couple of points on here. Now, I don't connect the lines. I definitely do not connect the lines. I just get the ordered pairs on there so I can see the line where it's forming. Okay, now from here, as I'm graphing it, I want to notice that I have a greater than sign. Okay, I have a greater than sign. This means that I'm going to do a dashed line because there's no line underneath it. So we're going to connect this with a dashed line. And we're going to be sure we make this line long. Don't make it too short. It needs to be kind of long so that you can see it. All right, we're almost done. Now, we've got it graphed. It's a dashed line. We just have to figure out, is it all the points up here or is it all the points down here? Because it's not an equal. It means it's an area. It's either all this or all this. So now you have to do what we call the shading. And in order to do the shading, you have to test a point. Okay, the point I always test, if I can, is this point right here. That point is 0, 0. And if I can test 0, 0, I'm going to test 0, 0. X is 0 and Y is 0. I'm going to plug it in right here. So that's going to be 0, and I'm going to go back to the black over here, greater than 1 over 4, and then I'm going to plug in 0 for the X, minus 2. So that says 0 is greater than negative 2. Is 0 bigger than negative 2? Yeah, it is. So that is true. Okay, what that tells me is at this point, I'm going to put a check mark, that point is in the shaded area because I got a true statement. If I'd have gotten a false statement, it would not be in the shaded, and I would have shaded on the other side. And the next one we do is going to have, we'll do that. But since that's true, I go, woohoo, and then I shade. So that means if I pick any point up here above this line, I would get a true statement. Now, something else to kind of just talk about. What if I were to pick this point right here? This point right here, this point is 0, negative 2. That is the y-intercept. If I were to plug that into the equation, it would be on the dashed line. Would I get a true statement? Now, I'm just going to kind of do that real quick over here. I'm going to say the y is negative 2. So negative 2 greater than 1 over 4 times, and you may not have room on your Freyer to do this, and that's okay. You can just watch, minus 2. Here's what happens. You get negative 2 is bigger than negative 2. What? Is negative 2 bigger than negative 2? No, that is false. Negative 2 is equal to negative 2, but it's not bigger than itself. What that tells you is this. Because it's a dashed line, that means it's not included. That means any ordered pair that's actually physically on this line is not part of my solution. The only coordinates that are ones that are out here in the shaded region. You can pick any ordered pair out here in the shaded region and you'll get a true statement. We call that being part of the solution. Any ordered pair down here on this side is not part of the solution. And any ordered pair on this dashed line is also not part of the solution. Okay, let's do another one. Again, you can go back and watch that if you need to. Example number 2. Here we go. Let's do 3x plus 2y is less than or equal to 0. Okay. Well, in order to graph it and figure it out, I have to solve for y. So I'm going to say solve for y. So that means I need to move the x and I need to divide by the y. So I'm going to come back over here. I'm going to move the x. 2y less than or equal to negative 3x. And then I'm going to divide by y, which is 2. And I'm going to get y is less than or equal to negative 3 over 2x. And I'm going to box that in because that's what I'm graphing. Now, you might have been like, wait, Mrs. Dean, why did we not flip it? Because that's a negative 3. Well, you know what? I'm going to make a note here. And I'm going to say, do not flip the sign. We did not divide by negative. We did not do it. So let's put a note here. Do not flip the sign. We did not divide, I'll just put the division symbol, divide by a negative. So we don't need to flip the sign. We didn't divide by a negative. Okay, now we need to graph. So let's do this. Let's say graph. And we're going to do y equals negative 3 over 2x. Okay, when I go to graph that, that's going to go through the ordered pairs here. Now, I am graphing these pretty fast. You may not be as fast at graphing as I am, and you may have to put it in your calculator or Desmos to get the graph, and that's okay. For the purposes of this video, I'm just graphing it pretty quick. The rise over run would be negative 3 over 2, so I'm going to rise negative 3, which means I'm going to actually go down 1, 2, 3. And the run is a positive 2, so it's going to be about right there. And then I'd go down 1, 2, 3 and run over 2, so it'd be about right there. Okay, I'm going to look, and this is less than or equal to. That means, put that there. Okay, that means a solid line. Okay, so I'm going to try and do a solid line through this. Solid line going up this way. There it is. Okay, now I have to figure out how to shade. Okay, so I need to test a point. Remember it said test a point? Let's say test a point. And remember I tested 0, 0 because that was the best point to test, but 0, 0 is on the line. I can't test a point on the line. So just find a point that's definitely not on the line. Doesn't matter which one. I'm going to pick one that's not that far away. I could do over 1, up 1. I could do over 2, up 2. I'm going to do 2, 2. So I'll do this. I'm going to do over 2, up 2. That's a nice one. I'm going to test that point right there. Okay, so here's what we're going to do. I'm going to plug 2, 2 in. And I'm using numbers that are the same, like 2, 2 or 1, 1 or 3, so that I don't mess up putting it in. You'll kind of catch that. So I'm going to put in 2, and then I'm going to do less than or equal to negative 3 over 2, and I'm going to plug in 2. Okay, so that gives me 2 is less than or equal to, I'm going to solve that, that's going to be negative 3. Okay, is 2 less than negative? No, 2 is bigger than negative 3, right? 2 is, so this is false, so this is a no. So this is a big no. Okay, this is perfect. That means that this is a no. So I'm going to put an X. This is not true. Since this side gave me a false statement, that means I shade on the other side. You just have to test one side. You don't have to test both sides. If this side gives you false, then that means you simply shade on the other side. If that side had given us true, we'd shade on that side. But it didn't. It gave us false. That means that any point over here in this side of the equation, over on our graph, any ordered pair over here is part of the solution. Any ordered pair that I pick over here would give me a true statement over there. All right, y'all. So that concludes your inequalities, and I'm going to pull this out a little bit so you can get a whole picture of this under here as best I can. I know it's not quite all under there, but there you go. I hope that helps. Good luck on the homework.